Suppose you are in this field where all the red bars are obstacles and you have to reach the green circle, and you started from here. So which path you will choose? So you may choose like this path to reach the green circle. But my question is, how can you code or make an algorithm to do the same, or to find a similar path without colliding with any obstacle? You may think like it's related to some data science or machine learning deep learning problem, but today I am going to show you a very beautiful algorithm related to biology, genetic algorithm. As it sounds, it's related to our genetics and all the DNA stuff going inside us from generations. So let me explain some of the genetics in some seconds. So in each generation, each organism has some DNA which carries some information about that organism, and as the generation goes on, the DNA gets better and better. So it's like changing and updating parameters in machine learning to get better results, and only better ones survive. So it's like new generation, which is in which the best ones are selected, they mates, and some mutation goes on and the new generation is generated. So how we can do something similar to all the genetics, but to solve our this maze solving problem? So let's look at it. So in this problem we can use genetic algorithm. So for genetic algorithm we must have some organisms. So this is our organism which is going to solve our problem, and each organism has their own DNA, which is some instructions to move like this, which is up, down, left, right, up, down, and so on. And we will do all the mating, selecting, and mutations with these organisms. So for example, this is our organism and the DNA is this, so he will move like up, right, right, up, right, which is very simple. And now we can also define mating for this problem. So mating is the process in which the next generation is generated, so for which we will choose the best ones, best solutions. But how we would know these organisms are the best solutions? We will define this using fitness function. So what is fitness function? As it sounds, it is the parameter which tells us how fit a solution is. So for this case, our solution is more fit, more better if it's more closer to our green circle, and our solution is more worse if it collides with any of the obstacle. So now we know how we can define the fitness function, and now we can select all the best solutions. But how we will mate? So for this we will select two parents and we will cut their DNAs in half. And now to generate the baby's DNA, we will take the first half from the first parent and add it with second half of the second parent. We can also introduce mutations and errors, which is just some errors while copying the DNA, which is done randomly. It's important to because it helps us to reach more variety of solutions and more different solutions. So this mutations and errors can expand our solution space. So now we are ready, so let's start our simulation. But before that, let me summarize all my code. So this is my rocket with all the necessary functions, like each rocket will have its own DNA and a function to move, function to update its location, and function to show it on screen and calculate its fitness. And the DNA, I also made another class for DNAs to arrange the crossover and mutation functions. There is also a population class to arrange population of millions or hundreds of rockets with all the functions evaluate selection, and these are all our parameters. So now we are ready to run the code. So let's see how well our organisms perform. Now we can see our organisms started to reach our goal. So let's see how well they find the path in last. So now after some 60-70 generations, we can see now our organisms are better enough to find the path. Some of the organisms are colliding with the obstacles because of some mutations or some different reason. So I hope you liked the video. Comment down below the next topic, and thank you.